Lesson 15, weighted averages. Our aim today is going to be let's use ratios to find specific points on line segments. All right, 15.1 part way, points. For the questions in this activity, use the coordinate grid if it is helpful to you. Well, I imagine it will be. All right, 1. What is the midpoint of the segment connecting 1, 2 and 5, 2? So I'm going to plot that. And again, I really hate how they don't do this in this. You got to name your points. 1, 2. Let's call that A. And B is 5, 2. All right, I can see that between them, it's a distance. Oh, wow, that is super bright. Sorry about that. It's a distance of 1, 2, 3, 4. So if I want to find the midpoint, I want to find a point that's equidistant between those 2 points. So that'll be right here in the middle. I'll call it M. All right, and that coordinate is 3, 2. You might also notice that since the y's are the same here, we're really just taking the average of 1 and 5. If you remember last year, to find the average of two numbers, let's say I've got a number x and y, and I want to find their average. What I do is I add x and y together, and then I divide them by 2, and that equals their average. Okay, so I could have added 1 and 5 over 2. That's equal to 6 over 2. That's equal to 3. You may also notice that technically we found the average between 2 and 2 as well. 2 plus 2 over 2 is just 4 over 2. That's equal to 2. So let's try that method for this next one. See how it works. All right, let's find our x value first. So the x is going to be 5 plus 5 over 2, or just 10 over 2, 5. For y, we're going to get 2 plus 10, which is equal to 12 over 2, which is really just equal to 6. So we should get 5, 6. Let's check to make sure that this theory works, right? Never just assume something works. So let's call this C and D. All right, maybe we'll call this M1 because it's the midpoint for problem 1, so don't get confused. All right, 5, 2 is C, so it's B and C, they're both there. And D is 5, 10. All right, so if I'm finding the distance between them, it's 1, 2, 3, 4, 5, 6, 7, 8. And so half of 8 is 4, so we'd be going up 1, 2, 3, 4. And that looks to be 5, 6, and that's exactly the point we got when we found the averages. All right. What is the midpoint of the segment connecting 1, 2 and 5, 10? So actually, really I should have called this point B because they're really the same. Because I see now that they're making what looks to me to be a right triangle, right? Looks like they're going to connect these 2 points now, A and D. Okay, so as you can see, it's going to be a little bit difficult to just count off. So we're going to need to use our method of finding the average between the 2 points. So if I want to find the average of my x's, I do 1 plus 5 over 2. That's equal to 6 over 2, equal to 3. And I can see my y's are going to be 2 plus 10 over 2, 12 over 2, it's equal to 6. So 3, 6 should be that midpoint. And it's funny that we're taking the x from the first problem and the y from the second problem to get this third midpoint here. Another thing we could have done here to find this midpoint let's say we're going from A to D, right? And this is technically really the same thing, if you think about it. If we're going from A to D, right, we can think of that as a rise over run. So if we're going from A, we're going up 1, 2, 3, 4, 5, 6, 7, 8. Right, so that change in Y is equal to 8. Our change in X here, okay, so if I'm starting at A, which is 1 comma 2, and I'm going to D, which is D is 5 comma 10, right, we can see that we add 8 to the Y and we add 4 to the X. Right, well, that's if we're going all the way. If I want to go half that distance, it makes logical sense that we would cut these values in half. So if I'm starting at 1 comma 2, I'm just going to add 2, and to my Y I'm just going to add 4, and that'll bring us to 3 comma 6. So there really are several different ways that you can look at finding the midpoint on a coordinate plane.